Hello everyone, welcome back to Alpine Hydroxide 784, and today in the mathematics series we will be covering the scalar and vector products in vectors. So first I will tell you what's the difference between a scalar and a vector product. So in general I'll just be looking at the point that they've written in the curriculum per se, and just elaborating on it in a way. Okay, so a scalar product in essence gives you a scalar, like a number, and a vector product will give you a vector. I think that's the easiest thing I can say first of all. And so how you get a scalar product, otherwise known as a dot product, which is, for example, if you have A dot B or something, and if you know the matrix of the A and B, like you get 1 2 3 4 5 6, you can just do 1 times 4, and then 2 times 5, and then 3 times 6, and you add all of the all of those answers together to get your scalar product. For the vector product of 1 2 3 and 4 5 6, I will show you the actual way of doing it, and it looks a bit like a shoelace kind of method. And yeah, from there you should be able to do any vector product without any issue. Just remember that particular XXX, the shoelace thing, and you'll get it. Okay. So for so what's the difference between a scalar and vector? What do they mean? What do they represent? Okay, so a scalar product, well, if in essence, if you, for example, took A dot B and you don't know what the numbers, you would basically be getting something like, I don't know, yeah, you will be getting a magnitude of A times magnitude of B times cosine theta, which is the angle between A and B. But for A cross B, you have if you try to get the magnitude of A cross B, because in this case you won't get a magnitude otherwise. If you get the magnitude of A cross B, you will be getting magnitude of A times magnitude of B times sine theta, which is the angle between A and B. So in essence, the scalar product is like the sum of the products of each of the coordinates for A and B, and the vector product is like, for example, if you have an A and a B and you have their theta in between, the angle, it's trying to find the vector that's perpendicular to both of them at the point that they meet or they diverge from. It's kind of like, if you can visualize it using your left hand or right hand rule. Only thing that the angle between A and B doesn't have to be 90, it can be any other number. So in for example, the scenario that theta is 0 between A and B, then in other words, maybe A and B are the exact same thing, it's just A dot A or A cross A. For A dot A, you'll just get the magnitude of A squared, and for A cross A, you will actually get 0, because there isn't any definite vector that you can specifically say is perpendicular to them, because there's an infinite number of vectors that are perpendicular to A dot A. A cross A, yeah. So yeah, that's why there isn't any solution and you get the 0 vector. So in this scenario, yeah, that's just basically how they work. So now let's move on to how you calculate the magnitude of vector and the angle between two vectors. Of course, last time we covered how to do the magnitude of the vector the normal way, which is just to take all the numbers and square them and then square root them. But in this scenario, in this case, in this subtopic, they are expecting us to use the dot or cross product to find the magnitude of a vector. So if yeah, for example, the, the dot product will give you a magnitude times another magnitude times cosine theta. So if you know the theta already, then you can just find the magnitude using that formula, yeah, that's what they expect you to do. And likewise with cross product, you can do the same thing. If you know that particular magnitude of the cross product, you can probably use it to find the magnitude of the vector. And likewise, you can use it to find the angle too, if in a sense, it is where we get our direction cosine. Last time I showed you the equation for direction cosine. So now let me just tell you what it means. In this scenario, the magnitude of, well, for example, a vector A dot, say I, for example, A dot I will be, so A dot I will be equal to magnitude of A times 1, because I is just 1, that's the magnitude of I is 1, and then times cosine theta, and therefore cosine theta is equal to the dot product of A dot I over A, magnitude of A. So what is the dot product of A and I? If you think about it, it would be actually, like, for example, if A is 1, 2, 3, and since I is just 1, 0, 0, you only will retain the x of the A. So in that sense, you just need to put the x value, the x coordinate on top, and the bottom is the magnitude of A. And that's how you get the direction cosine for the x-axis. And likewise, you can do the same for the y and the z-axis, and that's why the direction cosine formula works. So this is how you relate this part to the previous subtopic, and yeah, let's move on. For the cross product, when you try to find the magnitude of the line that is perpendicular to both A and B, what are you trying to do? Well, you can use this in the next topic where you're learning about lines and things like that, and you can use it to find the angle between two vectors. And in essence, yeah, if you have like two vectors meeting at a point and you want to know what, like if you have a plane, for example, that connects both of them, in order to find the plane, you can use this line, because this line is perpendicular to that plane. So yeah, it could be used for that purpose if you think that's a sensible purpose. Yeah, otherwise, yeah, that's just a general idea of it. And of course, we do know there's the whole thing where you can calculate the area of a triangle and everything, because you know that the area of a triangle is, if you have a normal triangle, you can, apart from the base height, half base height, there's another formula which, if you have a triangle with length ABC, you can, for example, put the angle at C, and you can say half AB sine C. So in which one has the sign? It's the cross product. So you use a cross product, you can get the area of a triangle formed by a bunch of vectors, and you can also get the area of a quadrilateral, which is twice the area of the triangle. So that's what the geometrical meaning of this is actually. And yeah, in that sense, I think you should be able to get what I mean. Okay, So if you extend this to a unit, if you bring it down to a unit vector, like how I have shown you with I, j, k, they are all unit vectors, or any other unit vector, the dot product will in essence, if for example, if you use the I and if you use I and A for example, um, you know that the I is only gonna be this much and the A is only gonna be this much. So what's in between? What connects the two of them? There's a line, right? You will get the length of the line, actually. And for the other cross product, you will get the length of a different line. So yeah. Where was I? Yeah. So if you get the magnitude of the line going this way, you get the length of the line that is perpendicular to both of them. And you can use this in the next subtopic, and you get to know more about it in the next subtopic. Yeah, I hope I make some sense. I'm sorry, I'm telling this at a pretty late time and I don't know what I'm talking about. Okay, just kidding. Yeah, so I think that's about it for that part. Yeah, I think there's nothing else to say. Well, I think we're done. Yay. So if I want to add anything else, I'll just add it on later. But if not, I would like to, if you enjoyed this video or you found it useful and you want to know about the next subtopic of vectors, please press the like button and of course subscribe to get notifications, I guess. I don't know if there's any notification bell anymore, but okay, fine. And with that, I would like to say thank you and bye.